This is a video for completing the square. So to start off, we have the equation 2g squared plus 4g minus 10 equals 0. So the first thing you want to do when you are completing the square is you want to see what your a value is. So in our case, our a value is 2. Remember, a is your leading coefficient. So ours is 2. You can't use completing the square unless your a is 1. So in order to have a be 1, you have to divide out by a. So divide by 2, divide everything by 2. So 2g squared divided by 2, 4g divided by 2, negative 10 divided by 2, and 0 divided by 2. So 2g squared divided by 2 is g squared. 4g divided by 2 is 2g. And negative 10 divided by 2 is negative 5. And then 0 divided by 2 is 0. So now we are good to go ahead and start using the method completing the square. So next, you want to move your constant term to the other side. So in order to do this, we add 5 to both sides. So we get g squared plus 2g plus blank equals 5 plus blank. So now we have to figure out what goes in the blanks. So to do this, we take half of our b term. So our b is 2, so we divide 2 by 2 and square it. So 2 divided by 2 is 1. 1 squared is 1. So 1 is what goes in the two blanks. So now the left side of our equation is a perfect square trinomial. So now we are good to go to factor. And the way we factor is we take the square root of the first term, we keep this sign right here, and we square root the last term. So when we do this, we get the square root of g squared is g. We keep the sign, and the square root of 1 is 1. So we get the quantity g plus 1 squared equals, and then we combine our terms over here, so 5 plus 1 is 6. So we get the quantity of g plus 1 squared equals 6. So now we are good to go to solve for g. So we square root both sides, and we get that g plus 1 equals plus or minus the square root of 6. Remember, when we square root something, we have to do plus or minus because the number could be either positive or negative. So now we subtract 1 from both sides, and we get that g equals negative 1 plus or minus the square root of 6. And to see if we can simplify the square root of 6, we write out the factors. So 2 and 3. Can't break 2 down anymore, can't break 3 down anymore. We don't have a group of 2 to pull out, so this is our simplified answer. So now we are going to put into words what we just did in problem number 1. So steps for completing the square. So first off, we look to see what our a value is. And so look to see what a is. If a isn't 1, then we have to divide by a so that our leading coefficient is 1. The only way completing the square works is if a is 1. So in our first example, look back, remember our a value was 2, so we had to divide everything by 2. So look to see what a is. If a isn't 1, then we have to divide by a so that our leading coefficient is 1. And we divide everything by a. Divide everything by a. Okay, and then after we got that our a value was 1, we moved our constant term to the other side. So move constant term to other side. So we move our constant term to the other side, and that's what we did in this step. Our constant term in this case was -5, so taking it to the other side made it +5. And then we rewrote our equation but putting blanks in. So then rewrite equation with blanks. And then when we did that, we had g squared plus 2g plus blank equals the 5 that we took over plus blank. So that's what I mean when I say rewrite your equation with blanks. And then after that, we figured out, so figure out what goes in the blank. And to do this, we take half of b and then we square it. So b over 2 squared goes in the blank. So you will notice, if you look back at your equation, in our blank we took half of 2, 2 divided by 2 is 1, and we squared it. 1 squared is 1. So that's how 1 got put in this blank and this blank. So then, once you do that, you are okay to factor. So, because the left side is a perfect square trinomial, and that's the whole point of this, is to get the left-hand side to be a perfect square so that solving is simpler. So, we factor our perfect square trinomial. And the way we factor is we take the square root, keep the sign, and then we square root again. So this is what our case was. If you look back at the problem, we had g squared plus 2g plus 1. So we took the square root of g squared, so that's where the first square root came from. We kept the first sign, and then we took the square root of the last term. So we square root first term, we keep the first operation symbol, and then we square root the last term. And then that gives us our factor. So if we look back right here, square root of g squared, that's how we got g, kept the sign, and then square root of 1 is 1. So we put this quantity in parentheses and raise it to the second power because this is a perfect square trinomial. And then we combine the terms on the right. So we combine our constant terms. So we factor and then combine constant terms. So we combine constant terms. And then we square root both sides to solve. So square root both sides. So if you look back at the problem, square root of the quantity of g plus 1 squared is g plus 1. Because what is this really? This is really 2 factors of g plus 1. So if you rewrite it under the radical, you have g plus 1 and g plus 1. And our index would be 2. So we need 2 pairs to pull out. So there's 2. So that's why the square root of the quantity g plus 1 squared is g plus 1. And then we took the square root over here, which is plus or minus square root of 6. And then we add or subtract constant term on the left to the right to solve for our variable. So if you look back, once we got g plus 1 equals the plus or minus square root of 6, we subtracted 1 from both sides. So then we got our final answer as g equals negative 1 plus or minus the square root of 6. So we add or subtract the constant term on the left to the right to solve for our variable. And then we are done. But if you get a square root like what we got here instead of a nice clean number, then you look to see if you can simplify the radical, which is what I did here. And in this case, I couldn't. So this was our final answer. So I'm going to add that as the last step. Simplify radicals. And you can also end up with fractions. So so just simplify radicals or fractions. Okay, so simplify radicals or fractions, and then you are done. Okay, so now we're going to try another example. So now, what do we first do? We look to see what A is. In this case, A is an understood 1. So we don't have to divide by A because our leading coefficient is 1. So now we can go ahead and take 7 over to the other side. Well, negative 7 to the other side. So when we do this, we add 7 to both sides, and we get x squared minus 14x plus blank equals 7 plus blank. Okay, so now, if you remember, what goes in the blanks, we take half of b, so half of negative 14 is negative 7, so negative 14 over 2, and we square it. So negative 14 over 2, so that is negative 7, and we square it. Negative 7 squared is 49, so 49 goes in the blanks. So now our left side is a perfect square trinomial. So now we factor. And how do we factor? We take the square root of the first term. We keep the first operation, and then we square root the last term. So the square root of x squared is x. Keep the sign, so x minus, and then the square root of 49 is 7, so x minus 7. So we get the quantity x minus 7 squared equals 7 plus 49. And 7 plus 49 is 56. So now we solve for x. So the way we do that is we square root both sides, and we get x minus 7 equals plus or minus square root of 56. We add 7 to both sides, and we get x equals 7 plus or minus the square root of 56. And then here in this problem, we're getting into where we have to simplify our radical. So we look at the factors of 56. So 8 times 7 is 56. We can't break 7 down because 7 is a prime number. We can break 8 down though. So 8 is 2 times 4. We can't break 2 down anymore because 2 is a prime number. We can break down 4. So we get 2 and 2. And now we have a pair of 2's to take out. So we get x equals 7 plus or minus 2 square roots, and then we combine seven and 2, and we get 14 left under the radical. So x equals 7 plus or minus 2 square roots of 14, is our final simplified answer. Okay, so now we're on example 3. So first thing we do, we check to see what our A value is. Our A is 1, so we're good. We don't have to divide by anything. So we take our constant term to the other side. So negative 2 over here. So we add 2 to both sides, and we get h squared minus 5h plus blank equals 2 plus blank. Okay, so now we figure out what goes in the blanks. So we take half of our b term. Our b is negative 5, so negative 5, and we divide it by 2, and we square it. So negative 5 divided by 2 is negative 5 halves. We square it, and we get 25 fourths, because negative 5 squared is 25, 2 squared is 4. So 25 fourths is what goes in the blanks. And to check it in the calculator, negative 5 divided by 2 and square it, and we get 6.25, so we hit math 1 enter, 25 fourths. So my mental math was okay. So now we are good to go ahead and factor, since our left hand side is a perfect square trinomial. So remember how we factor. We take the square root of the first term, we keep this sign, and we take the square root of our last term. So the square root of h squared is h. We keep the sign, so minus. And then the square root of 25 fourths is second square root 25 fourths, and we get 2.5, so math 1 enter, so 5 halves. So h minus 5 halves quantity squared equals, and then we see how much 2 plus 25 fourths is. So 2 plus 25 fourths equals 8.25, but we want it in fraction form, so 33 fourths. So now, if you notice, this one wasn't pretty like the other ones we've been doing. So it does happen when that you get fractions, but if you leave them as fractions instead of leaving them as decimals, they're easier to work with as fractions. So now we square root both sides to solve for h. So we get h minus 5 halves equals plus or minus square root of 33 fourths. So now we add 5 halves to both sides, and we get that h equals 5 halves plus or minus the square root of 33 over 4. And if you remember how square roots with fractions works, this is actually h equals 5/2 plus or minus the square root of 33 over the square root of 4. And the square root of 4 is 2, so we get h equals 5/2 plus the square root of 33 over 2. So if you wanted, you could write this as plus or minus. You could write it as h equals 5 plus or minus the square root of 33 over 2. So this way or this way is acceptable. But make sure you simplify, because square root of 4 does simplify to 2. And now for the last one. Okay, so this one is a little different from the other ones. If you notice, your constant term is already on the right side, so you don't have to add or subtract it over. And your a value is 1, so you don't have to worry about dividing anything. So now we can rewrite our problem. So we can rewrite it with the blank. So we get v squared plus 10x plus blank equals 11 plus blank. So the way we figure out what goes in the blank, we take half of our b term and square it. 10 is our b in this case. So half of 10 and square it. So 10 divided by 2 is 5. 5 squared is 25. So 25 goes in the blanks. So now we can factor. Our left-hand side is a perfect square trinomial, which is the whole point of completing the square. So the way we factor, we take the square root, keep the sign, take the square root. So the square root of v squared is v. We keep the sign. And then the square root of 25 is 5. So we get the quantity v plus 5 squared equals 11 plus 25. And 11 plus 25 is 36. So now we are good to solve. So square root both sides. And we get v plus 5 equals plus or minus square root of 36. So we get v equals, we subtract the 5 over, so we get v equals negative 5 plus or minus the square root of 36. But what is the square root of 36? It is 6, so we get v equals negative 5 plus or minus 6. So what is negative 5 plus 6? So it's positive 1. So v equals positive 1, and then negative 5 minus 6 is negative 11. So v equals negative 11. And we can check this in the calculator if your middle math isn't all that good. So negative 5 plus 6, we get 1. So v equals 1. So we were right on that one. And then negative 5 minus 6, and we get negative 11. And here we have v equals negative 11. So we're good here too. So these are the solutions to our problem of v squared plus 10x equals 11.